Welcome to Lesson 311, Intro to Exponents. Today we're going to talk about how to convert numbers from exponential form to standard form, how to convert numbers from standard form to exponential form, and how to simplify expressions with exponents. Right, so when you look at a problem that has repeated addition, we figured out a shortcut to repeated addition and we turned it into multiplication. So we took 6 plus 6 plus 6 plus 6 plus 6 and turned it into 6 times 5. So knowing that, when you have problems that involve repeated multiplication, there is a way to make a shortcut for repeated multiplication. Right, so to shorten up repeated multiplication, we use exponents. And the exponent itself tells how many times a number is multiplied when written in exponential form. So the exponent is the small number, and it tells you how many times to multiply the other number. So here's your example, 3 to the 4th power means that you're going to take 3 and multiply it by 3 4 different times. So the 4 right here is the exponent. So what you might want to do is you might want to circle it, or if you have the ability to write it in a different color, that would be helpful too. The base. The base is the number being multiplied when written in exponential form. So in this case, when you have 3 to the 4th power, 3 is the base number because it's what's being multiplied, and 4 is the exponent. Power, a number that can be expressed using an exponent. So this is where your solution comes into play. So I have 8 is a power of 2 because 2 times 2 times 2 is equal to 8. Or the other way you can say this is 2 to the 3rd power equals 8. So because 2 to the 3rd power is equal to 8, 8 is a power of 2. So in this case, you have to remember 8 is the power, so you might want to actually circle the 8. Squared. Squared is when a base is to the 2nd power. So when you hear feet squared or yards squared or a number squared, it's because you have that number or that unit to the 2nd power. And then cubed is when a base is taken to the 3rd power. Okay, so typically squared and cubed are the only forms of exponents that have their own words. Otherwise, you just say something to the blank power. So in this case, it's 3 to the 4th power. This is 3 squared, and this is 3 cubed. Again, you'll want to circle each piece here that is in red with each word, so that way you know what goes with what. All right, so when looking at this, when we change something to exponential form, we have to look at the number that's being multiplied. In this case, the number that's being multiplied is 4. So 4 is going to be our base, our big number, and then our exponent is how many times that number is being multiplied. So I have 1, 2, 3 4s. So this is going to be 4 to the 3rd power. All right, so I want you to take a second and I want you to try this one on your own, and when you come back, I'll check your answer. All right, so your base in this case is 3, that's what's being multiplied, and you have 1, 2, 3, 4, 5, 6 of them, so it is 3 to the 6th power. Okay, so that's just changing it to exponential form. Now we're going to take a number that's in exponential form, we're going to find the base, the power, we're going to write it in standard form, and we're going to find the solution. Okay, these two things are completely different. So standard form is when it's written as a multiplication problem. Exponential form is when it's written with exponents, and the solution is the answer to this. So in this case, the base, what's being multiplied is 2. The power is 7. So to write that in standard form, I have to take 2 and multiply it by 2 7 times. So I'll have 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6 times 2. Okay, I apologize, we ran out of a little bit of space there. So now the solution is actually doing this math. So you can't do 2 times 7. 2 times 7 will get you 14. This is incorrect. So let's see what we actually get here. If you take 2 times 2, you get 4. But then you still have all these other 2's that you have to multiply by. Those 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then you have to do 4 times 2, which will get you 8. Times 2, times 2, times 2, times 2. So now you're getting 16 times 2, times 2, times 2. Here you get 32 times 2, times 2. Here you get 64 times 2. So the solution to 2 to the 7th power is actually 128. That's going to be a lot different than 14. So you have to remember, it doesn't mean the base times the exponent, it's the base times itself, the number of times that you have the exponent says. All right, so I want you to try this one. When you come back, we'll check your answer. So here the base is 6. It's a power of 4. As standard form, it would be 6 times 6 times 6 times 6. So as an answer, 6 times 6 is 36 times 6 times 6. So 6 times 6 is 36. 3 times 6 is 18. Plus 3 is 21. So times 6. 216 times 6. 6 times 6 is 36. Carry the 3. 1 times 6 is 6. Plus 3 is 9. 2 times 6 is 12. So the solution in this case is 1,296. Okay, and we'll see exponents now when we use PEMDAS. So when we have the E for exponents, so remember it's PEMDAS. Now we're actually going to use that E. So in this case, we look for parentheses. We have none. Exponents, we do have some, so we have to do that first. So we have to solve 2 to the 5th power. Okay, so now if I'm using a calculator, which sometimes you will be able to do, there are parts of a calculator that let you put in something to the 5th power, and I can show you each on your calculators how to do that. Otherwise, we can just type it in like this as in standard form. 1, 2, 3, 4, 5. Okay, and we get 32. So we have 64 divided by 32 plus 10. Now I know I need to divide, and I get 2 plus 10. My answer in this case is 12. So I want you to take a moment, and I would like you to solve this one on your own. When you come back, we'll check your answer. All right, so here you should have gotten 27 divided by 3 times 4 minus 12. 27 divided by 3 is 9 times 4 minus 12. 9 times 4 is 36 minus 12. As an answer, you should have gotten 24. If you did not get that answer, I do want you to go back and check and make sure that each line of your work matches mine. If it doesn't, that should show you where your mistake was. Again, the biggest mistake is that students will put that 3 to the 3rd power is 9, but you have to remember it's 3 times 3 times 3, which turns into 9 times 3, which then turns into 27. All right, so where we would use this. So if you have a situation like Maria has, where she won a grand prize on a game show, she will be given $2 for the first month, $4 the second, $8 the third, and so on. So as the payments go on, she gets payments doubled for 1 year. So we're going to create a formula with exponents that will show how much she will make in 1 year. So first what I want you to look at is the first month. I'm just going to make my own little table here. The first month, she gets $2. As a multiplication problem, there's nothing. It's just $2. For the second month, she gets $4. That turns into 2 times 2. For the third month, she gets $8. So it's not that the month and the number are giving you an answer. The month is completely separate. So in this case, it becomes 2 times 2 times 2 because it's not The 3 that's doubling, it's what she got last month that's doubling. So if you look at this for the 4th month, how much do you think she should get? If you said 16, you're correct, because 8 times 2 is 16, so this becomes 2 times 2 times 2 times another 2. So for every month that there is, we add another number. So to figure out how much money she gets, we would have to put together an exponential problem. So we would have to take what she gets the first month, which is 2, and we would have to add 2 to the 2nd power plus 2 to the 3rd power. Now the reason we're adding these is because the first month she gets $2, then she gets 4, then she gets 8, then she gets 16. So it's not that she's getting 2 this month and then the next month she gets another 2 and then another 4. She gets 2 and then another 4, so she gets 6 plus another 8, so that's 14, so on and so forth. So you're going to add all these all the way up to 2 to the 12th power, because there are 12 months in 1 year. So these dots in here mean you should have 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, 2 to the 10th, 2 to the 11th, and 2 to the 12th. And then you would add all those together, and that would give you how much she would make in 1 year. Now, I'm not looking for an answer here. I'm just looking for a formula. When you write out formulas for real, you need to make sure to include this whole piece. But for the sake of time, I'm going to just move on. All right, so here you have your own problem to do. If Dana's school closes, a phone tree is used to contact each student's family. The secretary calls 3 families. Then each family calls another 3 families, and so on. How many families will be notified on the 6th round of calls? So again, the first round is 3 calls. The second round is 9 calls, because each of these calls another 3 people. So 3, 6, 9. And then the third round is going to be 27. So I want you to create your formula, and I want you to figure out how many people will be called by the 6th round. Okay, and I don't want to know the total, I want to know just the 6th round. How many people will be called during the 6th round? So use what we learned in the last piece to try and put together your formula. Again, always try. If you have any questions, please be sure to post them to Edmodo.